Hello and welcome to SudoKanard. We're here to solve this extra large region Sudoku from the recent WPF Sudoku Grand Prix organized by Thai authors. And so the special rule is that this long line here of length 18 contains all digits from 1 to 9 exactly twice. And my guess is that this represents a character from the Thai alphabet. But I've been too lazy to just check that I'm not saying something stupid. So I attempted the puzzle during the contest, and guess what? I finished it, I completed it, and then I typed the solution code, and there was only 1 minute or so remaining, so I just looked a second time, and I saw that one of the digits appeared only once, and another digit appeared 3 times in this area, so I knew that my solution was wrong, and I'll be trying to do better in this video. So what I'm seeing first is that we have a lot of given digits, and 4 and 2 can't be anywhere in here, so we get right from the get-go a 2-4 pair in there, which is quite interesting. We also have a 9 here and a 9 there. Oh, by the way, this table here is something I've added to keep track of which digits have been placed along the line and how many times they appear. Oh, and actually, because I saw only this 9, but there's also this 9, so I can place a 9 here, and I can say that I've got the 9 exactly 1 time at this point. So let's look for a suitable place for the second 9. We can see that the given 9s remove all those positions, and this 9 removes those positions. So along the line, the second 9 must be here. So this is already 2 digits placed in the grid. Let's do some standard Sudoku pencil marking. There must be a 9 somewhere here. Because of those, there must be a 9 somewhere here. Because of this 9, well, a lot of places here. Because of those 9s, 2 places for the 9 in here. That's not so impressive. 5 here, 5 there. So there will be a 5 somewhere here and somewhere in there. So here I need 1, 5, 6, and 8. So this is from 5 and 8. This is from 1 and 6. And 2 of those digits will appear in here. But other digits are very restricted. This 2 with this 2. So I know there will be a 2 somewhere in here. So where can 2 go along the line? We know that 2 is nowhere in here. It's nowhere in here. So we're left with 3 places for digit 2 along the line. And we know that only one of them can have a 2. So this must have a 2. And the other 2 is up there. So we have 1, 2 located with certainty, and I would almost say 1.5, because the second 2 is somewhere in one of those 2 positions. With this 4, and this 4, I get this 4. 3, 7, 8, so this must be a 6, and that's a 1. And here we have 3, 7, and 8, and that's not a 3 because of this here. Here we have digits from 5, 6, and 8, and we know that there is a 6 in here. Three seems to be very restricted along the line. So here I can't have a 3 because of this. I can't have a 3 anywhere in here because of this. Can't have a 3 there. So I'm only left with this cell and those two cells for 3. So one of them will have to be here and the second 3 will have to be there. So I could say 1.5 for the same reason. This column needs a 7 because of this. The 7 must be here, so that's one instance of 7. So same question along the line. 7 won't be here because of the given digit. So the second 7 will have to be in one of 3 positions, which is not so helpful, I'm afraid. This too disambiguates that. I could have noted this much earlier. So 4. 4 is nowhere in here. So I get a 4 somewhere here. So that's a 4 along the line. Where is the second 4? And I'm tempted to say that it's here. So let's just check. There is a 4 in this box. Because of this, I can't put a 4 anywhere here because of this 4. Oh, it could still be here. So this, we could have the 4 here and there, or a 4 there. Oh, actually, because of those 4s, there must be a 4 here. And it pushes the second 2 there, so we have all 2s, and there's a 4 here. So the second 4 is in there, and that's it for this digit, I think. 6 is not here, so in the column it must be here, and those are from 178. That's not the 7, so the second 7 will surely be there. There's a 1 in here along this row, the 2 here, and the 2 there. Oh, actually, this is a 2, 9 there. So 3, 5, 7, 8, there's an 8 here, so this is 5 or 7, this is 3, 5 or 7. So what digits are still to be located along the line? A lot of them, actually. In this column, I still need 1, 5, 6, and 8. So this here is from 1 and 8. 5, 6, 8. All four digits are possible here. All 4 digits are to be expected in here. What about this? 1, 2, 3. This can only be 4 or 6. And actually, with those 2s, I can place a 2 here, which disambiguates the 9-2 pair at the bottom. So on this row, I still need 1, 4, 5, 6, 8. So this is 5 or 8. So 3, 4, and 7 have been virtually located. There's a 6 here. How am I just doing all of this? 8 is not here, so 8 will be in one of 2 positions. Here the candidates remaining are not... Actually, there's a 4 in one of 2 places here. With those 4s, it places a 4 there. So this can only be a 6 or a 7, I think. Yes, that's correct. By the way, I didn't mention it at the beginning, but in my opinion, this puzzle is much more difficult than the 46 points. that appear here. I think it's really more difficult than that. Well, I'm still missing obvious eliminations, like the fact that 2 goes there. I still need 1, 5, 6, and 8 in here, so this is from 1, 5, 8. 1 and 8 here, 5, 6, 8 here, 1, 5, and 6 here. So maybe that's not so useful, but I'm seeing that 6 is somewhere in here, so that's never a 6, and the 6 on this row must be here. So where else should I look now? I think I will pencil mark the fact that those are from 1, 5, 6, and 8. So how many 1, 5, 6, and 8s do we have in those cells? We know that here one of them must be 7, so one of them will be 1, 5, 6, and 8. And that's a total of 6. I need 2 more. And the 2 more will be in here. With the 3 and the 4, well, that's only obvious what I've been stating here. So I must be missing something not so difficult, but I'm really not seeing what. This is from 5, 6, and 8. So 4 is here. Oh, and on this row, 6 must be somewhere. And that's interesting, because I know there will be a 6 in one of those cells, and I know that 6 will be somewhere in here. So I've located globally where the 2 6s are along the line, so I can remove 6 from the options there. Well, I was being enthusiastic, but I know that 6 won't be here either, for the same reason. I got a 6 here and a 6 there. So there is a 4 and a 6 here. Oh yes, that's true for 4 as well. There's a 4 here, there's a 4 there. So I can't have a 4 here along the line. I already have 2 4s. So the 4 in this box is here, and that's a 6. And that's a 7, and this is probably what will simplify everything. So this is one instance of 6 along the line. The second instance is in here. We have all 4s. There's still a 3 in here. Still a 6 there. 1, 5, 8. So this is a 6. So there is a 5 in here. Six here tells me that the 6 in this region is there. So that's not 6, and that's the second 6. So here, 1, 5, and 8. This row still needs 3, 5, and 8. There's 3 and 5 here, so that's 8. This is from 3 and 5, and this is also from 3 and 5. Here I get a 9-4 pair, so that's the 9, that's the 4. And I can place this 9 up there, and this 9 here. This is from 5, 7, 8. This column also needs 5, 7, and 8. And this, oh, there's an 8 here, so that's a 1, that's a 5, that's an 8. So no 5 here, and this is a 3. I get the 1 here, that's a 5, that's a 3, that's a 7. This is 8, this is 5, this is 8. That's 1, that's 7. This is 3, this is 7. This is 5, 8, 7. So everything is just falling into place. That's not the 1, that's actually a 5. Those are 1 and 5. Now, this here must be a 3. So that's the 3. And this is 1 or 8. And 1 or 5 up there. So let's keep track of all digits. We have placed both instances of 7. This is true for 3 as well. So what about 1, 5, and 8? Here I have 5, 8, 5. So I have 2 instances of 5 along the lines. So this is not a 5 anymore. That's 5, that's 1, that's 5. What about 1 and 8? There's an 8 here. So here, that's 8, that's 1, that's 1, that's 8. And now I have 2 instances of all of them, and removing this, I trigger the result. The fact that the constraint holds until the last disambiguation is really, really great. I do think that this puzzle is much more difficult than the 46 points that have been attributed, but well, this is my personal issue with all that uses geometry in the puzzles. Thanks for watching this video and see you soon on SudoKanard.